Welcome back to the classroom. My name is Mr. Wong, and in today's lesson we're going to be looking through a physics question from Module 5, Inquiry Question 3. This is going to be on Kepler's laws of planetary motion. So let's have a look at what the question is and what will we need to do to solve it. We have two planets, X and Y, that travels anti-clockwise. So we can see them moving in the anti-clockwise direction, like so, in circular orbits about a star, as seen in the diagram. The radii of the orbits X and Y are in the ratio of 2 to 5. What I can say is, arbitrarily speaking, the length from planet X from the star is 2r, and the length, I'll change the colors, to planet Y is 5r. That's what we have. The planets are shown below at a time interval of 5 years. Initially, they were aligned, making a straight line with the star. 5 years later, the planet X has rotated through 120 degrees, as shown. So from our starting point here is now 120 degrees past. In the question, it says determine the time it takes for planet Y to make one orbit, so one full rotation around the star. So say this was our starting point. We want it to go all the way around back into here. All right, so that's quite a lot of information to unpack here. As you would know, to find the time, we will be using Kepler's formula, or Kepler's law of planetary motion. So in this case, we're using r cubed over t squared, and given the fact that we don't have the mass of the star, we would be equating it with r cubed over t squared, given the fact that the two planets are orbiting around the center planet. So the value of this ratio is going to be constant regardless. R and t will not be the same for the two planets, but the constant in which they come together will be and should be the same. So the first thing is, remember, t, or capital T, represents the period. So the time it takes for one revolution to occur. So one complete 360 circle to occur. Now the information we have here, as you can see, after 5 years, it's gone 120 degrees. What that tells us is that's not the total time taken for one revolution, but a third of it. So there's two ways you can go about working out the value. I know that in a whole circle, it is 360 degrees. And so there are 3 components of 120 degrees to make a whole circle. So if I multiplied by, 5 years multiplied by 3, that would imply that it takes planet X 15 years to make one full rotation. Another way we can solve this is using what we talked about with circular motion. So I know that 120 over 360, that is our, you can just call it our angular displacement, okay? So that's our angular displacement, and I can also say that equals to 1 over 3. So my total period, the period taken, would be the number of years taken, so the time of rotation, which is 5 years, over 1 divided by 3 rotations, and that would also give me 15 years. Okay? You could do it this way we showed here, or you can write it this way here. This links back to circular motion. This obviously is just going off the maths that we can see right here. So it takes us 15 years for one full rotation for planet X. Okay, let's put our numbers in. So I know that the radius for X, or in terms of the distance from the star, is 2. For Y is 5, and for the time of rotation is 15. What we don't know is Ty. So going back to the formula we had earlier, so this one up here, we have 2 cubed over 15 squared equals 2. What we have 5 cubed over t squared y. And so ty is what we want to find. We want to rearrange the formula around. So we'll move ty over onto the left-hand side. So it's ty squared equals 2 3 cubed multiplied by 15 squared divided by 2 cubed. And so ty is the square root of 5 cubed multiplied by 15 squared divided by 2 to the power of 3. And from there, that gives me a value of 59.29270,613. Let's look at what's this lowest significant figures provided in the equation. Well, it's a bit hard to tell because we're doing it in years. So realistically, it is 59.29 years. But if we want to round it off to whole numbers, it's roughly 59 years for a full rotation, for planet Y to have a full rotation. As you can see, the second half of this question isn't that difficult to perform. It's just a regular substitution, but it will take you a little bit of effort just to think really carefully about the total time it takes for one revolution to occur, and just to recognize that capital T always refers to the time it takes for one whole revolution. That completes the question. If you found this video useful, like and subscribe, and I will see you next time.